All right, so I've got the cosecant of x plus the cotangent of x is equal to 1. I think that it would probably be best to turn these into sines and cosines just so we know exactly what's going on. So I can rewrite the cosecant of x as 1 over the sine of x. It's the reciprocal identity. Plus cotangent can be written as cosine x over sine of x equals 1. All right, cool. So now I have 1 over the sine of x plus the cosine of x over the sine of x equals 1. If you'll notice, these have a common denominator, so I can just add the numerators together. Okay. And then now, this might be a little tricky to think about, right? But if I were to turn the right-hand side into a sine squared x, and I were to turn the left-hand side into something squared, I would end up with a trinomial in terms of cosine squared x on the left, and I would end up with a sine squared x on the right. I can then turn the sine squared x into cosine squared x using the Pythagorean identity, and then I can have everything in terms of cosine squared x and regular cosine x. So that's what I'm going to try to do here. So what I'm doing here, right, is I'm going to cross multiply. And I get 1 plus the cosine of x is equal to the sine of x. I'm going to square both sides. So that way I have cosine squareds and sine squareds, and hopefully I can rewrite one in terms of the other using the ultimate Pythagorean identity. Check it. Double distribute. All right, so now I've got everything in terms of cosine on the left, and I've got a sine squared on the right, which I can just turn into a cosine squared using the Pythagorean identity. Okay, so then now I can start sorting stuff, right? Okay, so now I've got 2 cosine x equals 0, 1 plus cosine x equals 0. All right, cool. I didn't even have to factor this one because the constant canceled, so that's pretty cool. I was planning on factoring it, but whatever, now my life is easier. Okay, so now I have the cosine of x is equal to 0. I'm going to subtract the 1. I have the cosine of x is equal to negative 1. Oh, hallelujah. These are just on the unit circle. This has become quite easy now. Okay, so cosine x equals 0. I'm looking where the x coordinate is 0. X is cosine. That's going to happen at pi over 2 and 3 pi over 2. Okay, and then cosine of x equals negative 1. So I'm going to be looking for where x is negative 1. That's going to happen at pi. All right, cool. So now I have 3 possible solutions. Why do I say possible solutions? Because the original problem is cosecant x plus cotangent x equals 1. Whenever I have reciprocal identities, now we're introducing this issue here. And this issue here is to take our original solutions and put them, or we're going to need to take our solutions and put them back into the original and see if they hold true. So remember, this is only occurring with reciprocal functions. You don't need to do this every time, otherwise you drive yourself insane, right? So I have 1 over the sine of x plus the cosine of x over the sine of x should equal 1. We are checking to make sure that all of these angle measures make the equation true. So let's first start with the pi over 2. 1 over the sine of pi over 2 plus the cosine of pi over 2 over the sine of pi over 2 equals 1. Okay, so we know that the sine of pi over 2, let's look back at our unit circle, right? The sine of pi over 2 is going to be 1. Sorry, I'm going to stop scrolling back and forth. I'll just leave it like that. Okay. The sine of pi over 2 is 1, so I have 1 over 1 plus the cosine of pi over 2 is 0 divided by the sine of pi over 2, which is 1. So 0 divided by 1 is going to be 0. 1 plus 0 equals 1. This is true. Pi over 2 is a true solution. It's going to work. Okay. Now let's test with pi. All right, so let's test with pi. Let's test with pi. I wonder if I can write small enough. Okay, we're going to test with pi. Does it equal 1? We're checking. We're going to check. Okay. So we're checking sine of pi, cosine of pi, sine of pi. All right, so 1 over the sine of pi. The sine of pi is 0. Oh, no, we can't have 1 over 0. So 1 over 0, we can't have that. So we would be rejecting the solution pi. Then let's check with 3 pi over 2. Okay, let's do 3 pi over 2, 3 pi over 2, 3 pi over 2. Sine of 3 pi over 2 plus the cosine of 3 pi over 2 plus the sine of 3 pi over 2. Okay, so sine of 3 pi over 2, let's look down. 3 pi over 2, the sine is going to be negative 1. So we have 1 divided by negative 1 plus the cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is negative 1. 0 divided by negative 1 is just 0. So we have negative 1 plus 0 equals 1. It does not. So we're going to reject the solution 3 pi over 2. And our answer is x equals pi over 2. And then just to see this graphically to deepen your understanding, right, I graphed cosecant of x plus cotangent of x. That was the left-hand side of the equation. I graphed the right-hand side of the equation. 1. I had my calculator in radians. I changed the interval to be from 0 to 2 pi, and these two graphs only cross one time at 1.57, which is equivalent to pi over